In this tutorial, we will be discussing enzymes. Enzymes catalyze nearly all the chemical reactions taking place in the cells and in the cells of the body. They increase the rate of reaction by lowering the energy of activation. Notice they produce the same amount. They just make it easier to produce. The name of an enzyme is derived by placing the end of the name of the reaction or a reacting compound with the suffix "ase". It identifies the reacting substance. For example, sucrase catalyzes the reaction of sucrose. It describes the compound of the reaction that is catalyzed. For example, oxidase catalyzes an oxidation reaction. And could be a common name, particularly for the digestion enzymes such as pepsin and trypsin. Enzymes are classified by the reaction they catalyze. There are 6 main classes of enzymes. In each enzyme, there's what's called an active site. On the surface of the enzyme, there's a small region called an active site that binds the substrate and catalyzes the reaction of the substrate. Look at the way that it's been bonding. We have hydrogen bonding, salt bridges, a hydrophobic area. Those 5 things that we learned with the tertiary and quaternary still hold here. We have hydrophilic, hydrophobic, hydrogen bonding, salt bridges, and disulfide bonds that can keep those steady and put in place. The active site is a region within an enzyme that fits the shape of the reacting molecule called a substrate. It contains an amino acid R group that binds the substrate and releases products when the reaction is complete. So here we have the enzyme and the active site. The substrate comes in and it binds together to temporarily create a new substance. And then the reaction takes place, and when it releases, we have the product, and we have the enzyme to go back and react with something else. In a hydrolysis of a disaccharide sucrose, for example, the ES complex is formed as sucrose binds to the active site of sucrase. The glycosidic bond of sucrose is in position for hydrolysis. The R group of the amino acid and the active site catalyze the hydrolysis of sucrose, producing glucose and fructose as the product. The product structures are no longer attracted to the active site, so they are released to allow sucrase to react with another sucrose molecule. There's a couple different models for the enzyme action. One is the lock and key model. The active site is very rigid. It's not going to change shape when the substrate comes in. The enzyme binds only substrates that exactly fit the active site like a lock, and the substrate is the key that fits the lock. The induced model is more flexible. This enzyme structure is flexible, not rigid, and adjusts to the shape of the active site in order to bind to the substrate. The range of substrate specificity increases. The shape changes improve the catalyst during the reaction. So here we have the enzyme with the active site, and here's the substrate. They come together. Notice that this is angled out at first, but now it fits nice and snug. So they work together to create something that actually does the job. And then you come down and you have the product left over, and the product goes away, and then as that happens, the active site goes back to its original shape. Alright, so let's review. The active site is simply a section of the enzyme. And in the induced fit model, the shape of the enzyme when the substrate binds adapts to the shape of the substrate.